Here are your notes for Unit 13, Day 3 of Pre-Calculus. If you would like to see the warm-up, the review question, or any homework questions we covered in class today, just look at the finished notes. So today we're going to move on from probability and talk about statistics. So today we'll talk about the foundational skills of statistics, mean, median, mode, which are the measures of central tendency. We'll talk about how to display data using different types of tables and graphs, like histograms, stem and leaf plots, circle graphs or pie charts, bar graphs. All right, so let's start by talking about the mean, median, mode, and range of a data set. So you probably remember what these words mean from middle school. So mean, how we normally describe the mean is the average of a number set. So you sum the numbers, and you divide by the total number of entries. So you add up all the numbers and then you divide by how many numbers there are, and that's how you find the mean. The median is the middle number. So you line up all of your data points from smallest to biggest. So you put the entries in order. So all of your data points you're going to put in order from smallest to biggest or biggest to smallest. We usually do smallest to biggest. And then whatever number is in the middle is called the median. If there is an even number, so there's going to be two numbers in the middle, then you you average the two middle numbers. So if there's an even number of numbers, then you're going to average the two middle numbers, and that's how you would find the median. The mode is the most repeated data element. So if there is a data element that's repeated more than any others, that's called the mode. And then the range is how far the data set spans. So you take the greatest data point minus the least data point, or the largest minus the smallest, and that will give you the range of your data set. So let's look at an example of this. Dr. Geringer gave 5 tests this semester worth 100 points each. Billy's 5 test scores were 78, 84, 67, 88, and 93. What is Billy's test average? So again, that's asking for his mean. So you're going to take all of his test scores and add them together. So 78 plus 84 plus 67 plus 88 plus 93. And then divide by how many tests he's taken. He's taken 5 tests. And so we'll just pull this up. And we're going to I'll put it in parentheses. So 78 plus 84 plus 67 plus 88 plus 93. And then we're going to divide by his total number of tests, which is 5. And so Billy's test average is an 82%. Dr. Geringer's Chapter 6 test scores for his third hour class were as follows: a 63, a 68, a 74, a 76, a 79, an 84, an 84, an 88, an 88, an 88, a 91, a 93, a 93, a 94, 95, a 98, and a 99. Now notice they are in order from the smallest test score to the largest test score. So we don't have to put them in order. They're already there. So now we need to find the median test score. So typically when there's a large amount, I just go and I subtract one from the end and subtract one from the start. And I keep going until I only have one left in the middle or two left in the middle. So notice the median score, the score that's in the middle of all of the numbers, is an 88. So the median score for his test, his third hour class, was an 88. What's the mode? Well, the mode is the most repeated number up there. So 63 wasn't repeated, 68 wasn't repeated, 74, 76, 79, 84 is repeated twice, 88 is repeated 3 times, 91 is not repeated, 93 is repeated twice. So 88 is also the mode because it was the most repeated test score in the class. If we wanted to find the range of the test scores of his third hour class, we would take his highest score, which is a 99, minus his lowest score, which is a 63. And the range of the numbers is 36. So from the lowest score to the highest score, there's 36 in between. If you wanted to find the mean of all of his test scores, you would add them all together. So let's add them all together. So we would take 63 plus 68 plus 74 plus 76 plus 79 plus 84 plus 84 plus 88 plus 88 plus 88 plus 91 plus 93 plus 93 plus 94 plus 95 plus 98 plus 99. Oops. And then we would divide that by how many total tests there were. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 total tests. So we're going to divide by 17 students. And his average test score, or the mean of his test scores, was an 80.647%. Now notice the mean, median, and mode are called your measures of central tendency. They're the numbers that show where the middle of the numbers tend to occur. I notice the mean and the mode agree with each other, both in 88, but the mean was an 80.647%, which means that the lower scores are affecting the overall total more than the larger scores. So let's make sure I typed all of those in. Oh, that's what had happened. So 93, 93. There we go. So it's an 85. I was going to say that seemed really low looking at that data set. So the mean of the numbers is actually an 85.588%, which makes more sense. And there you go. That's how you would find mean, median, and mode of a data set and range. The mean of 12 numbers is 15. What is the sum of the numbers? Okay, well, if you added up all of the numbers and you divided by 12, you'd get 15. So if they want to know what the sum of the numbers are, you would just take 15 times 12, and that would give you the sum of all of those data numbers. So the sum is going to be 15 times 12, which is 180. So the sum of those 12 data points would be 180. All right, dot plots, stem plots, and histograms. So if you had a data set, you could arrange that data set in a couple different types of graphs. One could be a dot plot, and a dot plot could be like, you know, you could have 1 of something, 2 of something, 3 of something, 4 of something, or like 5, and then and this could be how many people had that. So 1 person, 2 person, 3 person, 4 person, 5 person, 6 person. So we could say like 1 person had 1 pair of something, 1 person had 4 pairs of something, 2 people had 2 pairs of something, 2 people had 6 pairs of something, 3 people had 2 pairs of something, 3 people had 4 pairs of something, and then 4, and then... So this would be a dot plot. You're just plotting how many over the course. So this could be the number of people. And this could be like their pairs of socks. So like 1 person owned 1 pair of socks, 1 person owned 4 pairs of socks, 2 people owned 2 pairs of socks, 2 people owned 6 pairs of socks, and so on and so forth. A stem and leaf plot looks like this. So you have a stem and a leaf. So this is if you have like large numbers in your data set. So you could have like 10 people or 11 people or 12 people, or you could have 21 people, 22 people, 23 people, or 32 people, 33 people, or 45 people, or 46 people. So this would be like the tens digit, and this could be the ones digit. And so it's another way of organizing data. We call that a stem and leaf plot. A histogram is like a bar graph pretty much. And so you could do, like, you know, if you were talking about favorite colors, and then number of people. You could have like blue, and pink, and orange. And you could say like one person's favorite color was orange, two people's favorite color was pink, and then you could say like three people's favorite color was blue. And that's what a histogram looks like. It's kind of like a bar graph. And so those are different ways of organizing data into graphs or charts. So let's look at some examples of this. How many pairs of shoes do you own? Record everyone answers here. So in class today, we recorded everybody's answers, but let's just put in some data points. So let's say we had 10, 8, 15, 35, 26, 12, 11, 9, 4, 36, 15, and 9. So let's say that we collected people's pairs of shoes, and that was the data set. Is the number of pairs of shoes a categorical or quantitative variable? So categorical would be like colors are categorical, or favorite subjects are categorical. Quantitative variables are ones that you can count. So like the number of pairs of shoes that you have would be quantitative, or the number of anything that you can count is quantitative. So like pairs of shoes would be quantitative. Categorical would be like your favorite color. You can't count that. It's just your favorite color is blue. So we are going to now, instead of doing this dot plot, stem plot, and histogram by hand, we're going to use a website to enter the data. So we're going to go to www.staplet.com, and it's going to let us make this data plot ourselves. So we are going to, oops, it still didn't want to do that. Here we go. So we're going to go to www.staplet.com. And then we are going to use this website to enter in our data. So we have categorical or quantitative. So this is going to be quantitative, and it's a single group because we're just going to do one thing, number of pairs of shoes. So it's the number of shoes that each person owns. So that's what we're going to title our table. It's raw data, and it says to enter it with commas. So 10, 8, 15, 15, 35, 26, 12, 11, 9, 4, 36, 15, 9, and we don't have any repeats, so let's add a repeat. We're going to add an 11, so at least one was repeated, so 11. All right, so we're going to begin analysis. And notice it gives me, right off the bat, it's giving me a dot plot. So the number of shoes and then in dot form. So how many people had 4 pairs of shoes, 1, or 10 pairs of shoes, 1, or 11 pairs of shoes looks like 2, or 15 pairs of shoes looks like 2. So that would be a dot plot. And notice you can change what type of graph you want. So we could do a histogram. So here is kind of like our bar graph, a histogram that all the bars are connected. We could do, and we can change the frequency. It could be relative frequency. So it's going to change it to % of people who own that instead of the numbers. We could do our width to be 1. And then notice it makes it for each number by itself instead of thicker that shows like, you know, the number of people who own between 5 and 10 pairs of shoes. We can also do a stem plot. So notice we have the tens digit and ones digit like I showed you. So 4, 8, 9, 9, 10, 11, 11, 12, 15, 15, 26, 35, 36. So that would be, so this website can do all of the different data sets for us. So let's sketch in our stem plot. So 0, 1, 2, 3, and then it would be 4, 8, 9, 9. 0, 1, 1, 2, 5, 5, and then 6, and then 5 and 6. So there's my stem and leaf plot. And then we can do a histogram. And so it goes the number of people, and then the number of pairs. So we had 4, was 1, and then we had 10 was 1, then 11 was 2, and then 12 was 1, and then we had 2 here, and we had 1, and 1, and 1, and then 1. So it kind of looked like that. So again, this website, instead of having to do it by hand, this website, staplet.com, will create all of the different types of data organizers for you. So describe the distribution of the number of pairs of shoes of your class. So the shape, any outliers, and the center. So if we looked at the shape of this, we can, look at the different things again. It's kind of spread out all over the place. There's no 10 in the middle. They're more, they kind of clump around 10. So there's like a clump around 10. So there's a lot of dots around 10. And then are there any outliers? So are there any numbers of pairs that seem way far out from anybody else? Not really. You could say like the 35 and 36 seem way bigger than everybody else, but And then where would the center be? I would say the center is kind of around 15. Like that looks like the middle of most of the data if there wasn't an outlier. So this isn't the best data set. Maybe our data set from class was a little bit more spread out well. If we went back to our histogram, and then let's change that number. Again, it's they're kind of centered, or they're kind of skewed more to the left of that graph. So they're skewed more to less than 20. And then there's fewer after 20. So, all right. So, do you think teachers have the same number of pairs of shoes as students? Here's a random sampling of the number of pairs that a group of teachers had. So 15, 8, 10, 29, 14, 7, 22, 35, 6, 15, 13, 12, 9, and 10. So now we're going to enter this data on our same website, but this time we're going to enter this data with the student data that we had before and the teacher data. And then we're going to make side-by-side data comparisons of the two. Oops, not that. We want this. So I'm going to take this data set, select all, copy, and then we are going to go back to beginning. Okay, so we are going to go back to our beginning, and we are going to do quantitative, but this time we're going to have 2 variables. Oops. Multiple groups, sorry. 1 quantitative variable with multiple groups. So again, this is going to be the number of shoes. And then group name 1 is going to be students. And then we can enter our data. So I'm going to paste that data that we had from before. And then the other one is going to be teachers. Then let's enter in our teacher data. So, 15, 8, 10, 29, 14, 7, 22, 35, 6, 15, 13, 12, 9, and 10. All right, so let's begin our analysis. So notice now it's giving us 2 different dot plots, but we can compare them side by side. So notice the spread of the data looks very similar. The number of pairs of shoes for teachers and the number of pairs of shoes for students both look to be hovering with 15 or less. If we looked at our stem plot, again, so notice the stem plot side by side. Again, they both look like they're hovering on the 10, so 15 and lower category. Very few of them are more than 15. Or if we looked at the histogram. So again, the teacher data looks more like it levels off nicely compared to the student data, which clumps and then goes to nothing. So if we looked at the histograms, the student data looks like this. So this is student. And then the teacher data looked more like this. So notice the student data looks like it has one hump and then a couple. And then the teacher data looks like it kind of levels off more like starts high and then goes low. So their shapes are a little bit different. But both look like they clump with 15 or less pairs of shoes. So that kind of looks more like the spread or the shape of the data. And the students definitely look like they have 2 outliers versus the teachers look like they more so only have 1 outlier, or a data point that looks different than the other datas. All right, so bar graphs and pie graphs. So this is another way of organizing data. So which of the following is your favorite elective class? You may choose only one. So again, we ran through this in class, but let's just say we did the following, and we had 8 of you liked art the best, 2 of you liked music the best, 10 of you liked physical education the best, 2 liked foreign language, and 5 liked technology the best. So identify the individuals and the variable. The individuals are you guys. The variable is your favorite class. Is the variable categorical or quantitative? It's categorical because it's not something that we would count. You wouldn't count your favorite class as a number of things that you own. It's just one category. So your favorite class is art, not the number of pairs of shoes you have is 15. So now let's go back to our website. We're going to go back. And now it's going to be categorical data, and it's going to be a single group. So it's going to be favorite class. And then we are going to do art. We are going to do music. We are going to do PE. We are going to do foreign language. We are going to do technology. And then we had 8. Nope. We had 8. We had 2. We had 10. We had 2. We had 5. And now we can begin analysis. And notice it's giving me a bar chart. So it's very similar to a histogram, except for the bars are separated. There's a space in between them if they would have been connected. So, and this is just a bar graph. And then we can change this to a pie chart if we wanted to. And then here's our pie chart of data. So you can compare data in a bar graph or in a pie chart on our website. And here's the summary. So it's telling us the frequency of people. It told us how many people, so 20 or 27 total people were interviewed, and then it tells us the frequency. So about 30% said art was their favorite, 7.4% said music, 37% said PE, 7.4% said foreign language, and 18.5% said tech. So now sometimes it's helpful to investigate more than one variable. So let's start by saying, did you like math? Do you like math or English better? And then after that, you're going to tell me what your favorite subject, favorite elective subject is. So for those of you guys who said math was your favorite subject, how many people do we have art? We would say that we would have 5 people said English and 3 people said math were their favorite subject. And then for music, let's say 2 and 0. And then for PE, let's do 5 and 5, and then foreign language, we'll do 1 and 1. And then technology, let's do 4 and 1. So now, find the percent of all students who chose PE. So PE was, and we already talked about this before, so let's go back to our bar graph. And so the total number of people who liked PE out of everybody was 10 out of 27. Which was approximately 37%. Percent of all students who chose math and chose art. So math and art was 3 out of 27, which is 3 divided by 27. It's about 11%. So about 11% of you guys, based on my data that I just invented, percent of the students who prefer math that chose technology. So who chose math would be 8, 9, so 13 people chose math as their favorite subject. And then of those, 4% chose technology. So 4 out of 13. And that would be about 30.7% of people whose favorite subject of math also had their favorite elective as technology. How many variables does the data table have? It has 2. And they're both categorical because they are your favorite subject, which isn't a number, it's a thing. Which variable would best explain or predict the other variable? So why did you choose that variable? So I think we had a conversation about this in class, but take a moment to think about which variable, choosing math or English, does that predict your favorite elective, or does your favorite elective help you predict whether your favorite subject is math or English? And then just kind of think through that and make an argument whether you think once you know your favorite subject is either math or English, you'd be able to predict what your favorite elective is, or if you knew someone's favorite elective, would you be able to better predict their favorite subject is either math or English based on that? All right, so let's go back to our website and let's restart everything. And let's go back. And then we are going to do 2 categorical variables. And we'll just do favorite subjects. All right. Oops. Math or English. All right, so we have math or English. And then we had our favorite guys. We had art. We had music. We had PE. We had foreign language. And we had tech. Not teach, tech. And then my data that I just invented was 3, 0, 5, 1, and 4. And then we had 5, 2, 5, 1, and 1. And then we can begin our analysis. And then here we go. So let's look at how it broke down our data. So here's a segmented bar graph, math versus English, and then your favorite subject. So notice between art, more people liked art if their favorite subject was English, music as well. PE looked even, foreign language looked even, and then it looked like tech, more people favored tech if their favorite subject was math. We could look at a mosaic plot, or we could look at a side-by-side bar graph. So math versus English, notice tech looks higher for math. PE looks a little bit higher for math. Music looks the same. Nope. Music was blue. Music looks higher for English. So there are different ways of organizing that data. Okay, how do the bars in the side-by-side graph relate to the bars in the segmented bar graph? Is there association between favorite core subject and favorite elective? If so, describe. If there's not an association, what would the graphs look like? Explain. So go ahead and looking at your graphs on STEP. Let's see if you guys can answer those questions. All right, your homework is your statistics practice problems